Good morning. Today I'm going to do experiment number 3, and I'm going to put all of the output pins from LS08 to respective LED lights. So first we put LED number 1 to pin number 3. We put second LED light to uh, pin number 6. Then pin number 8 for third LED light. And finally, LED number 4 for LED number 11, pin number 11. For our first table, we need input A and B. Input A is pin number 1 and input B is pin number 2. So what I'm going to do here next is that I'm going to disconnect my resistors, which turns off input number A and input number B. Our first truth table is 0, 0, meaning both A and B are in ground. As you can see, the first light for our first output is turned off. If the light, if one light is open and the other one is closed, the result will be none because the gate is an AND gate. And again, uh, the input A is closed, the input B is open. So the result of the AND gate wouldn't light up number 3. I put back them from open for both input A and B. So what will happen is that our light number 1 will come back again. The result is the same for input C and D, input E and F, and input G and H. The second part of the experiment is the 3 input AND gate. What we're gonna do is connect uh, pin number 3 to pin number 4. And that's how you have 3 input AND gate. So we're going to connect uh, pin number 1 and pin number 2 as our A and B. Pin number 5 as our C. So what I do here is I connect them to positive VCC so that we can see that the LED lights are connected well. Then I connect pin number 6 to pin number 1 again. LED number 1. So you can see the LED light here, yellow. And what I'm going to do is I'm gonna put input A, B, C to 0. Don't forget to remove the resistor in pin number 4. Otherwise, it will cause a light up. So our input is 000, 001, 010, 0111, 100, 101, 110, and 111. As you can see here, we have two yellow LED inputs, I mean outputs as 1 as a result. When input ABC is 1, the result of L1 and L2 will be 1, 2. For our third part and the final part, we're gonna do for input AND gate. So this will be the result of the 4 input uh, 4 input gate AND gate, which is combined from A, B, C, D. And if we look closer, uh, all of them light except this one. So we want to light this in the 5th input gate, and we'll come back shortly. So this is the 5 input AND gate uh, light up. So I'm going to do here is that I'm going to remove one resistor and see what will happen. So here I remove one resistor yet. Uh, so I put the first pin to negative and see what will happen. As you can see, the first light turns off because again when we put the positive resistor, first positive resistor to negative, this will happen. All of the lights will turn off because in the AND gates, if one is negative, the rest will be uh, if one is 0, the rest of the output will be 0. But if we uh, if we exclude the first two pins, like put negative to 0 put negative to pin number 6, only one will open up because the first two resistors are positive. And I connected their output as AB to the first LED, which is lighting up currently. And they're all positive VCCs for now. Then what happens if I uh, input put the 8 output as negative, I 8 pin as negative. So we lost two lights, but the first and second LED was open. because again the first two pins are positive and the sixth pin is positive. Therefore, it wouldn't affect the subsequent ay subsequent subsequent lights other than this further from VCC. I mean pin number 9, 8, and 11. And for the final one, I put the pin number 13 to negative or ground state. So you can see here, there's no light in between these two lights, and that's lead number 4, I believe. And its next to it is 5, 6, 7, and 8. So none of the light does work if we put to negative VCC or ground. Then I put it back to VCC. So that's all. Thank you for watching.